Give me some updates.
About math.
Math, sure thing.
We started on sequences and series,
You
but we
start-
only did one question.
the tutorial, right?
Yes.
Okay, good. Hopefully the tutorial will be useful. All right. Nothing much to say. Yeah, you have finished that already, right? Okay. How about the lecture?
Math lecture.
Yeah.
We're on applications of differentiation.
Which
The
means,
last thing we went through is what? The strictly increasing, strictly decreasing.
Okay. Sounds O level, correct?
Yeah.
The application is also O level, right? Basically, with maybe the new differentiation thrown in, maybe.
The differentiation is hard.
It's hard.
I found some weird questions.
Feel free to ask, right? Okay.
I think I still have some like sequences questions in the Jamboard, right?
Let's see. And we're using a lot. Okay, so we have the page 8. We did until where? We did until the 3B, not no, the 3B done, right? No, 3B done. And then the 4B also done, right? So the question 80 at page 18, page 19, correct? Yeah. Okay, maybe today we'll do a new Jamboard, right? Okay, so which one first? Your differentiation or the series first?
Just the series.
Okay, right. So let's try something. Okay, so I still want your tutorial to be useful. I mean, it really mean that, okay, you have a problem and then go to the tutorial.
I'm not asking for every question here. There's some questions that I do ask the tutorial. Yeah.
Okay, good. Because if this is all that you have to ask, then I will leave one, right? Leave one at least for tutorial. Okay, so let's answer this. Okay, fine. Okay. Sure. Right. So your 72 pi is it's radius 12. Sorry. Yeah. Okay. Great. Okay. Sounds good. Okay, all looks good so far. It's geometric progression, and then given that the total area, okay, right, is 10 pi. Okay, and is 10 pi more than the 10 pi more. Yeah, more. Yeah. Okay, good. Plus 10 pi. Okay. Yeah, everything looks good here. So, what's your question?
I don't know how to continue.
Okay, so we acknowledge the basic math. The basic math is that this is 2 unknown and 2 equations. Correct.
Yeah? Then just key this into the GC.
I'm always tempted to think like that, right? Especially when the polynomial to be so difficult, but admittedly it is solvable, right? Admittedly, if it is possible to solve this using GC, I think I'll just do that. Right? I think so. Could you try that while I think about if there is a a manual way of doing it? Okay. As for Yankin, hear me now.
Yeah, I can.
All right, cool. Maybe.
Okay, wait for RGC, right? 2 equation, 2 unknown. We only have this.
Yeah, not the linear one. Definitely.
Yeah.
So again, the y and the x in your thing doesn't work, right? So
yeah,
well, we have to do something manual. So at this point, I feel something like this. I feel that the APGP is done. I feel that we are now just in math. So if this is a problem, we first acknowledge that, oh, okay, the problem is not at APGP, just so happened that, the first part is APGP lah. Okay.
Yeah.
So I suppose sometimes they do that. Sometimes they do that in exam, but I think the APGP is fine. Yeah. Is there anything else? Oh, goodness me. Right. Okay. So I feel that, okay, I take my word back. Now, obviously, there's nothing wrong with what you wrote here. There's nothing wrong, yeah. But you haven't tried one more thing. That one more thing is APGP, GP in this case. So I feel that you have not tried the SN of GP. I feel. Now, don't erase all this. Don't erase that. Just keep it there for our reference. But I feel that you should try SN, S8, the formula, right? It means you should try that, and let's see what happens, right? So will that help us more? Okay, Yankin, give me some updates.
Yeah, okay. So since Tuesday, there's been no math so far.
Okay.
Math is tomorrow, but we're not going through the paper. We're going through sample estimation tutorial.
Good. Yeah.
For today, we did chem we did transition metals lecture. And then and then we went through the paper.
You can do both, right? Okay.
Yeah,
okay,
so there are two periods.
Wow. Okay.
Right. For physics, not much really. We just did practical yesterday. That's about it. I don't think there's any physics until next week.
Okay.
Right. So since Tuesday, it's just been chem, going through papers, starting transition metals. I think we're gonna start transition metals tutorial tomorrow.
All right. Sounds not surprising, yeah. Everything is simple. So what should we do today?
Well, for math, tutorial wise, I'm quite fairly ahead. I'm almost done with hypothesis testing. And I'm already done with sample. So I think we should move to chem.
Right, quickly then. All right. Now, you haven't tried anything like
for transition metals.
Yeah.
I have.
Good. Right. Put it on there.
Let me get the.
Right. Let me be with Keiko, and then I'll look at your video. Okay, I would prefer to deal with the S8 rather than your original S8, definitely. If only we have another equation which can be more easily solved, right? Which I think I can. I think, and again, I'm gonna deal with SSN form, right? So I'm looking at this, right? And I don't like the polynomial situation like at all. So I wish for something more like this. And I would say that I can see this as a new SN. I can also see this as a new SN. When I say new SN,
there's like skips in between, though. Like,
no, you're looking at as the old SN. However, what I mean is that a new SN simply means that, okay, I might have a new first term, and I might have a new R log. I might, feel free to do that, right? Feel free to do that. I'll give it a try.
Okay.
Right, for both, and let's see where that leads us. Okay, Yankin. I see there's some
all right.
MCQ.
I'm not too far into the transition metals yet. I think I've only just like for me, I'm here at the lecture, so I've only just reached the end of ligands, but I'm not too good at that yet, like drawing it and stuff like that.
No
and they're
problem.
complex.
So far, no problem. Complex will be what we're aiming for, lah, right? But then later.
Yeah.
So what's your question?
This one, I'm not sure what I'm supposed to be doing here.
Right. Question 5, right?
Yeah.
Okay, I'm gonna copy that. Wait. Which ion was the dark blue? Okay, dark blue is very usually suspiciously, right, copper and very intense copper. When the excess of ammonia, okay, right. So I think his question. Oh, but there are other ions which have the blue color also lah. There are lah. And for example, the CND is trying to say that it is a complex because transition metal will form complexes with water lah. At least most of them, right? Most of them with water. So CND, and the complexes usually still have that very similar color with only the C2+. In fact, I think in A level you shift to the understanding that there is no C2+. There is no Cu2+. There is only Cu2+ complexes with water, for example. Okay, just to be clear, I think that's what they're aiming for here, but you must understand the shift. In fact, the A and B is also a complex, but it's also just a complex with the ammonia ion, which is also a question in itself. Is it possible? So we are already at complex, and that is one of the aim of the lecture note. So if you don't know, you go back to your complex because back then we also don't cover much. We should go back there and try to understand what's going on. You're saying that the lecture note haven't reached here?
I think it's almost here. Like we should be there.
Then, right? Yeah. So we need this. We need this, and this is not difficult if you understand the basics, and it is important. Right? So read again one more time. Just read again one more time. What's complexes? If this is your first time or you're trying to really understand. For you, Keiko, wait, let me think. Hi, I don't get what you're writing. Huh? What? What are you looking at? That, sure. You don't need the UN though. You don't need the UN though. Because if you draw a UN, you already have it in long form, right? It won't change your situation too much, but you want the S lah. So, for example, this SN, which involves this, will have the first unit as A lah, right? Correct. So you're going to write down A, but the ratio you will realize is not R. It is going to be R square, right? R square, and then up to 4 lah, So R square, but 4. Okay, so we have the R8, but the bottom one will be slightly different, no? 1 minus R square. Correct? Correct. Make sense?
Yeah, that's what I was doing.
Oh.
Yeah.
Oh, then you get what? Now, how did you get that? What?
What?
How did you? Wait, what's your gender?
Because I remember the other time, like, try to express in this form, right? Like, at least get this thing here. I don't know.
Wait. Are you trying to go to this simpler form from this more complicated form?
No. Like this is UN, right? Then from here I can get the ratio one.
Oh no, you must see it from here. No. You're thinking of ratio is very complicated. It's obvious that the R square is obvious that sorry, what's happening to Gempo? It's obvious that the Gempo is acting up. It's obvious that the R square. It's obvious that the ratio is R square just from what you wrote already. Do you even have to find it really? No, wait, no. From A to AR square is R square. From AR square to AR4 is R square lah. It's obvious from what you wrote.
Okay.
If that makes sense.
Yes.
Now do the similar thing here. So what's the first guy, and then what's the R, and then and see where that leads us. Right. And Kin, are you saying that the shapes are new to you? Is that what you're saying?
I mean, they're not new. I know them.
All right, right. Okay. Just confirming. Right. Okay, we have that. Yeah, and then will be this guy equal to that guy plus 10 pi, right? Okay. Right.
I mean,
Oh yeah. I will prefer this thing much better, Keiko, in terms of pure math. Like, okay, you want me to handle this? I would rather handle this. This guy plus the first S8 look. I think I'm seeing some connection already. Maybe I can combine them. I don't know. Maybe. Definitely better than the polynomial situation. Right. So give yourself around 5 minutes. See whether we can go somewhere with this. Oh yeah. I definitely prefer this much more. Definitely. Yep. Definitely. Okay, so the first practical complexes that you learn is the ion metals, right? The transition ion metals with H2O, whereas previously you encounter a lot of other things. But aqua complexes are a special topic. Let's just say, right? Let's just keep this in mind. Right? This is going to be how we see cations, at least transition cations from now on. This is how. Okay.
Okay.
So read, and let's see what happens.
Form complexes. Okay. There is a very obvious comparison between this guy, right? Okay, I'm gonna put this as 3, right? Let's just put this as 3 and 1 lah. There's a very close comparison between 3 and 1. Hopefully we can do something about it, right? Check it out. Oh yeah, very close. Very close. Very close. Right, check out 3 and 1. Yeah? Are you okay, Yang? How come you're skipping until the end? What's going on here? Oh, I'm just going back to the question.
Okay. Sure. So let's just assume that all of them are going to be dark blue color. Let's just assume that. So the dark blue color doesn't help a lot here. Doesn't help a lot. But even considering just the charges, you can already eliminate 2 options already. Because one of them is positive, one is negative, positive and plus 1. Just like that, you can eliminate the possibility already, right? Then you can decide whether it's ammonia or H2O, which I feel is quite obvious lah. Which one would that be lah?
H2O.
Then how does the excess ammonia help? Or rather, how does that play into part there?
With the sulfate, like to break up the ionic.
You mean copper sulfate is solid, and maybe copper sulfate is not soluble? Really?
I mean, I suppose it is. Yeah, it is.
It is
sulfate.
It is. Definitely it is.
Then,
so the ammonia doesn't do that job, right? So, do you see anything, Keiko?
Oh wait, my Apple Pen died, so I'm just gonna do it on paper.
Sure. But focus on 1 and 3 first. And if this is your nice submission, then don't do it here first. Figure out what's going on first. Maybe using another piece of random paper. Do you see the connection between 1 to 3? I suppose I'm.
I do, but.
Yeah.
I'm thinking back to like qualitative analysis, but I'm not even sure how to.
Wait, let's solve it. No, let's stop. Now, let's say you choose the H2O one, let's say, rather than the NH3 one. Let's say. So, at least in the H2O one, you have to select between the positive and the negative. That itself should be obvious already. So D is wrong, right? So if there is no other discussion in your mind, then C is the answer, right? Okay, C is the answer, right? But I'm just, giving some, possible, possible leeway that maybe the ammonia one is correct. Then the charges should also still reveal to you who is right, who is wrong, right? It should, right? The charges should still reveal to you. So it's gonna be 2+, it's gonna be 4+. Is both possible?
I don't think 4+ is possible. Isn't ammonia is neutral, isn't it? So it's 0.
I guess I can agree with that. That's what we know. Okay.
So
B is wrong, right? B is wrong.
Copper can copper go up? No, copper can't go up to 4+ because it's all the way at the end.
I agree with that. Copper is only 1+ or 2+. Agree, right? That's what we know also. So B is gone. So the option is A or C lah. Then I just leave it to you lah. Meaning I'll leave it to your tutorial to solve this lah. Okay.
Okay.
This should prompt you to think a lot about complexes lah. Is one right. Right. Moving on.
Right.
Maybe we don't have complex. Oh, see. Oh, well, yeah, we have complexes. Yeah, we are there. They should be obsessed with complexes. Yeah, definitely.
CuNH34. Isn't that? CuNH34H2O2.
Sorry, which one are you looking at? Question 8.
Oh, yeah, question 8. Like 6 and 7 I can do as well.
Right, sounds good. Let me copy this. Okay, nice. All right. So again, tell me what's your problem.
Drawing is fine. Where is it?
Hopefully. Is it correct, Keiko?
It's correct. Yes.
Is it? Oh, it is. That's so weird. I wouldn't do it this way. Okay. What?
Yeah,
But you're correct, right? So cannot be wrong.
I tried 2 ways. This is my second way.
What's your first way?
Wait. I don't know. I did something like.
Okay. Right. Okay. Wait. I'll just show you another option because remember, even though maybe my option is better, maybe it's worse, right? Maybe, right? But in exam, if you got 1, you're happy, right? In exam, right? Okay. So this is my way when I see 1 and 3. So my point is not whether it is better or worse. My point is that when you're learning, you should see more than 1 option when it is possible. That's good for exam, right? So that's 72 pi, right? Considering 1, correct?
Oh, okay.
Right. So I tend to see this a lot in A-level stuff. It's like, oh, the substitution might feel non-traditional, but it ends up being very convenient, and that's why I like it lah. But I'm not talking about the superiority or the inferiority. I'm talking about just can you see things more? That's the learning part. Okay. Now, would you try doing this? See whether it is also the same answer. Then they have options. You have options. Okay.
My answer is correct, but sure.
Try this one. Just for a few.
Oh, there's another part C.
I'm losing your video for some reason.
I think that might be me. Can you? Oh, sorry. Can you? It's the same thing as last time. Can you be on the Zoom meeting? I'll mute from that.
Oh, really? But it's fine. Yeah. Okay.
Yeah.
Let me try. Right.
That'll be quick.
Okay.
I get the same thing. Mine just has pi in it.
Right. Fair enough. Okay. Feel free. Okay. Removing you. Yeah.
Yeah.
Okay. No, don't. Okay, done with that, yeah? Done with that. Okay, cool.
Yes.
So I'm checking page 19, yeah? So blah, 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 blah. Okay, fine. That should be okay. Is this not the first time you do this this is probably SNGP lah, SNGP of all this loaning and stuff lah. So what is your problem for this one?
No, this is my first time, yes.
Wait, your APGP tutorial and your practice is your own practice haven't reached this kind of question a lot. This is your first time. Oh, this is important. They like this a lot
Yeah.
in exam, but it is also one of the more practical one. I feel this is one of the more practical one for life. So hopefully that helps. Now, you didn't write anything, or at least did you write something? If I can see something, then try.
Hang on now. This is questions.
Okay. Okay, Yankin, you're back. I can see you. Yeah, good. Is question? This is question
part
6.
One, but I don't have anything for part 2.
No worries, no worries. So this is question 6, right? I'm gonna copy that. Done. Okay. All right. Okay, I'm gonna write something. You go ahead for that. If this is new, then I'm gonna write something. Yeah? Give me some time. Okay. So, Yankin, what's your question for that thing?
I'm not sure how to use like stoichiometric ratio to do.
So C, right? C, right? Okay. So yeah, okay. The hydrobenzoate is given, right? Okay, good. Wait. Yeah, everything's given. Right, okay. Right. So whatever fancy things stoichiometric ratio means is ratio, not ration. Yeah.
Yeah.
It simply means that I will take 1 and 2. However, it doesn't mean it's actually just 1 and just 2. It can be 2, 4, it can be 3, 6, it can be, well, any possible combination that gives you 1 to 2. You can think of this like the empirical formula, right? The 1 is not really 1, the 2 is not really 2. Fair enough.
Okay. Yeah.
Okay, so that's what he's telling me. Okay, I'll take that. Right. Okay, I'll take that. And I do notice that the hydrobenzoate ions are negative, and the ion is positive. It's 3 plus and 1 negative. But then again, complexes never follow the 3 plus and negative thingy, right? Complexes never care about that. Correct or not? Oh, you're 3 plus, I'm 1 plus. Oh, then I should go 3. You should go 1. No, complexes doesn't work like that. That's molecules. That's ions, right? Just to be clear. So I hope you're not surprised when the ratio is 1 to 2.
Yeah, I don't
just
think so.
All right. Okay, good. So well, usually complexes have 1 center, the positive ion. Usually,
yeah, definitely 3 plus.
So yeah, unless we are suspecting that to not be the case, then we are just assuming that it will be 1 F3 plus in the middle and 2 of this guy, I don't know, left, right, or whatever, right? Not too sure what's going on right now. Yeah, but that's only the initial assumption. So let's see what's the real question. Because if that's the only thing, then obviously the answer is very that. But maybe you're throwing us some curveball, something difficult, right?
Likely coordination number, I'm gonna go and say it's 2.
Yeah, the problem is, but no one. In A level, they never show you a complexes which have more than 1 center, right? It's just it's always
no,
1 center, right?
No, I don't think there's.
Yeah,
no, I haven't.
Here? Yeah, I don't think so. No, I'm not suspecting anything else. I suspect that is the case, that like the center is 1. Let's just proceed with that, right? I'm not sure what's going on here, but I don't think there is anything else going on. Right, so just try that. Just try that.
Oh, I need to write the Roman numerals. Right? Yeah. So, overall charge.
If it's really 1 and it's really 2, then it's quite easy to guess, right? Okay, for you, Keiko, yeah. This is right. Okay. Right. So I'm gonna write something, and you tell me whether it makes sense or not. Because I'm surprised that you didn't write something, right? This is probably okay. Sorry. Let me correct this. Back then, when I was going through this with Yankin, I'm very surprised that his lecture note only covered this once at the end. It's very weird that a lecture note would do that, right? So I'm gonna write something and tell me whether you have seen this in lecture note. Maybe a lecture note is also weird. Okay, so I'm writing something very simple, or rather, I'm just following what the question is saying. So this is first. I noticed that. And also this is first. Okay, good. And then on the last thing. So I just noticed all these things that I think I need to pay attention strongly. So January, if I write January, and then maybe I'll just, first and last, just to help me out. Just to help me out. Okay. So on January 1st, and then it'll be 100, right? On January last, that it will be 100 times 0.5%. Okay, nothing complicated. This correct? Then February, first and last. Again, to help me. So in the first, you will have that guy, right? 100 times 0.5% plus 100 lah, correct? Then on my last, then I will have 100 times 0.5% square plus 100 0.5%.
Actually, I think I did do something like this.
And that was what I would expect, because that is very helpful. That's very helpful. Right?
Okay.
So how do we when do we stop doing this? Is when we get to the end, right? On the last day of the end. So some people feel comfortable doing 3 first before doing the end. Some people feel comfortable doing that. Some people feel comfortable after 2. I will just suggest 3 if you don't feel comfortable. Right? But at that point, it should be very obvious what's going on. That means the pattern. Okay. And at that point, it should be very easy to do. That is the hope. That's the hope. Right? Your Apple Pencil is on. Okay, give it.
Yeah.
Right? Okay. So Yankin, right? Okay.
That's my guess, but the charge is gonna be +1.
I mean, I have no reason to voice, right? I have no reason. I mean, complexes charges are not very complicated, right?
Right.
It's just So if this is gonna be 1 and 2, then that's what it should be, right? The shape I may have some problem. Why? What's this?
I'm not. Oh,
what is going on here? Right?
This is like this is our problem.
I mean, we go linear. No, there's no other way about it, right? It's not gonna be tetrahedral. It's not gonna be off. It's not gonna be octahedrals. It's not gonna be all that, right? So linear,
What's the disposition? What's disposition mean? Like, I don't get what arrangement.
Nothing new. It is this is super similar to VSEPR, right? The molecule shape. Correct. So meaning he wants you to draw the 3D shape if the shape is 3D, but linear is not 3D. If everything is linear. So what you did is done. I mean, that is the full structure of the complex ion, and you're showing the 3D-ness of the shape, which is not.
Okay.
Okay. Right. Okay. And for now, that's it. But I'm checking what's going on here. I'm really checking what's going on. Like, what the heck is going on here? right? So move on to the next one first. We don't have much time yet. So if I notice something, I'll tell you. What the heck is
Yeah, I think that's as far as I get for learning wise.
Oh my goodness. I forget something, right? I forget what I said. Okay, I forget what I said myself, which I'm a nonsense. I'm nonsense. I apologize. So I did tell you that from this moment on, any transition metal cations should be viewed as complexes. There is no naked Fe3+, for example. There is no such thing.
Okay.
So we don't start with a naked Fe3+. We start with whatever possible complexes with water, a hydrate, hydrate, and then you will start to have a better picture of the total ion that we're talking about. You understand what I'm saying?
Okay, so
now the stoichiometric ratio does not include the hydrates, does not include the H2O. So you can still have one Fe3+ and two of that guy, but you have extra H2O playing a part. That's my guess, because that is the meaning of the complex topic in transition metal. You no longer have a naked transition metal cations most of the time. Even if there is even an exception, actually I don't think there's an exception. I don't think so. Okay, that's why the hydrate one, I'm a bit surprised that you skip through it, or you're just not reading it very much. Your note is not telling you that, or
I mean, they do go into aqua complexes.
Yeah, the note should tell you when it is a complex and when it is not. Now, just to be clear, for example, the +1 and the +2 of Na+ and Ca+ never form complexes. You covered that previously, by right? But 3 pluses already must form complexes. They also tell you that. That's not new. This is just repeated here. And then comes the transition metal. Then comes. Okay. You are not reading the hydrate one. You're reading the non-hydrate one. The hydrate one, only one page. That's how your note treats. Your note never say things that what I say.
I mean, what happens?
For example, there you go. Yeah, aqueous solution. So even though the question say Fe3+, he immediately assumed the octahedral. Right, the octahedral can change to something else. Fair enough. It can. But he immediately assumed that it is not Fe3+ naked. Immediately. You see my point, huh? You see my point.
Okay.
We have to move from there, Are you okay, Keiko, so far?
I got this. I'm trying the calculator now.
You're not using SN? That means you're not using the SNGP formula. Of course, you're using sigma. Sigma is great. I like it. But you're not using SNGP because SNGP is the most beautiful thing on earth, right? Right. And he's very sad that you're ignoring him a few times already. Previous question, this one question. He's begging you to use him. Really.
So if we assume octahedral, then where does the hydroxy benzoate go?
Yeah. So the benzoate is as you have learned from organic chemistry is
what, an ion?
It's acidic
Oh,
it's carboxylic acid. Did you not realize that?
But no, the carboxylic acid is acidic, right? Here it's
acidic it just releases H+. It releases the H+, so that's why it's become COO -1.
Yeah, but that means
let me ask you, is it?
Yeah, can.
No, it's not. Okay, fine. It is possible. Wait. Let me say this carefully. Yeah. I suppose it is possible to it is possible to assume that the H plus is not flying around. It is, I suppose, possible. And yet this is reversible. Huh. No. He won't let you go there. Can you see the up page? I'm very curious about what your lecturer is saying. Your lecturer doesn't seem to be saying much. Very weird to me.
That's not much.
Yeah. That's all very normal. That's all very normal, right? I'm not seeing anything else here, right? Yeah, this is all very normal. It's very weird to me. Anything for one. Now, disrupting the hydrate ion is not easy. What is this question trying to? Okay, you know what? For me, since I'm already assuming the Fe3 plus will be octahedron, right? There'll be six coordination number, right? I'm already assuming that no matter what. Okay, never mind the acidity and never mind the effect of acidity and whatever else, never mind that. Since the question already tells me that the 2-hydroxybenzoate ion will be there. He's telling me that 2 will be there. So I just have to replace 2, right?
That's it.
And I have to replace 2 in a way that they are very far from each other because they're very big compared to hydrates. Hydrates are very small. So if I can do that, then it doesn't matter how I draw. It can be up and down. Top bottom is fine. Left and right is fine. Diagonal left and right is also fine. As long as they are the furthest from each other. As long as, right. That's what I feel because the space he needs space basically. Right? That's all I'm thinking right now. That's all.
All right.
That's what I'm thinking. So now we change the answer. Part 1 coordination number, I think is still 6. The overall charge is still the same. The shape
plus 1
drawn, then the full structure will be what you draw, right? Okay, so at this point, you just have to add the 4 hydrates, right? Never mind the acidity and the things, but be careful. This is what they aim for, I feel. This is what they aim for, this kind of thing. Okay, for you, Keiko, are you okay so far? You are using the essay way. What are you doing now?
I don't think it's correct. The calculator is showing me very weird stuff also.
It seems that you are alternating between Sn and Sn plus 1. Now, why would you do that? Oh. Okay. So let me try to understand what they're doing. You are disturbed by this, I suppose. The n plus 1, maybe that's my drawing pen. Are you disturbed by the fact that it's n plus 1, where you're supposed to be n minus 1 instead, maybe?
N minus 1.
Because for Sn, right? For Sn of a GP, you expect n minus 1. Oh, sorry. I'm sorry. Why am I talking about? You do expect n. I'm so sorry. My mistake. I was thinking.
So I just leave it as n.
No. If that is what's bothering you, that's not very difficult to handle. I feel. Let me see. Yeah, I think so. Yeah, okay. So look at all this. Look at all this. This whole long thing. I can factorize this thing out. I can, right? Can factorize it, and then I'll make this except that it still needs to be n minus 1, right? So is that a good idea for me to ask you to do? Right? Okay, so again, just to repeat, in a proper UN, you will end with the n minus 1, right? If it is the nth U, correct or not?
For GP,
for
it
GP.
must end with
n minus 1, if that makes sense.
Oh, yeah,
correct. If it is n, so that's where the Sn will apply well. If the UN is n minus 1, then the Sn will apply well. So this thing is telling me that, oh my goodness, you have n plus 1. I need to use Sn plus 2. That's what I'm trying to say. Correct?
Yeah.
Not even as n plus, not even. So maybe that solves your problem. Maybe we can do it another way, but at least I'm trying to say that's your GP lah in action. That should be your GP.
So okay, wait. So wait.
Yankin, you're okay. So yeah, I don't think you should be just drawing the CO2 minus, like you should be drawing the whole thing, like just saying.
Yeah, I know.
Right. Okay. So any other question for this one?
This is about as far as I got for. I haven't even touched into color yet.
Not bad. But the complex, pay strong attention to it and gain knowledge in it. Right.
Okay.
More than the rest. The rest will be important, but more than the rest, this should be your you should be aware of this. Okay. So when I see you on again for this week, don't forget to take rest normally, right? Friday night, Saturday. When I see you on Sunday, what should we be doing?
Well, probably. I'm not sure.
No, you know your situation. You know your situation right now, right? Your physics is at the entering revision, right? Basically, right? You'll be doing the paper revision. Your chemistry is doing this last chapter. You know that, lah. Yeah? Your math, is doing the proper tutorial, right? You know where you are, right? So it should not be very difficult to predict what you can do for Sunday. Shouldn't be.
I think
you know what's going to happen on next week, right? This is nothing new. What's going to happen on next week? Very likely this and that, right?
The continuing chem transition metals.
Yep, that's very likely.
Physics, I'm not sure what the plan is. He only tells us the plan. For math.
Okay, let's pretend you don't need to do anything for physics first. Let's just follow let's see what the school is doing now. Right?
Then it'll probably be chem.
Then you want to discuss more of this tutorial on Sunday, right?
Yeah.
For math, you feel that you're still, but you'll probably run out of your head start by Sunday, probably.
Oh yeah, definitely.
So maybe just do a little bit of math on top of the chemistry, you do a lot more. Put it another way, if you can, you're stuck a lot, then just do more math.
Okay.
Okay, makes sense? That will be a productive Sunday before we meet.
All
right. See you on Sunday.
All right, thank you.
Bye-bye. So, Keiko, I predict that we won't have much time. So this is confusing for you, I suppose, yeah?
Yes.
Let's talk about it more on Sunday.
Sure.
Will this be discussed before?
No, not at all.
Yeah, we.
I don't think we even have math lesson left this week. So yeah.
So I did a wrong assumption. I assumed that you could do this kind of question. That's bad of me. So it's good on Sunday. We'll practice more. Feel free if you want to try more, but don't be so stressed if you cannot do.
Yeah, it's okay.
More, right?
I'm almost done with my differentiation. I'm just left with questions that I don't know how to do, and it's not that many. Yeah.
Wow, you are definitely way ahead, right? Okay, good. Then we can spend time on Sunday on this. We can do, maybe 2 more, hopefully. Then you feel some.
This should be the last. Yeah.
Really? There's no other APGP question on.
There is, but I was planning to attempt it myself after this. Yeah.
After this. Yeah, those kind of things. These things like given this and this kind of thing is important. Okay. For now, do what you want because you're ahead, and I'll see you on Sunday.
Okay.
Right. Bye.
Bye.